Today we're going to start 7.2 graphing hyperbolas. And first thing we'd like to do is sketch the graph of y equals 1 over x. So if you don't have a graphing calculator, that's fine. I'm just going to type in 1 divided by x and look at the graph. And then I'm going to sketch that. Ooh, I don't want orange. That's weird. So this graph is a weird C shape in the first quadrant and a weird C shape in the third quadrant. And if you were to draw in a horizontal line like that, these, if you folded the paper, these would be perfect reflections of each other. The big thing that I want you to notice is that there is a horizontal asymptote at y equals 0, and there is a vertical asymptote at x equals 0. So we have both. We have two asymptotes to think about. The vertical asymptote, vux, is at x equals 0. The horizontal asymptote, hoi, is at y equals 0. Now, the first type of hyperbola that we're going to look at is this form. So it's a number over x plus or minus a number, and then something else added or subtracted after. So here's our first example, 2 over x minus 3 plus 4. I graphed that earlier and put this picture of the graph up. And I want us to look for the horizontal and vertical asymptote and see if we notice anything. So the vertical asymptote is very easy to see. It's right here, and that is at x equals 3. Think about x equals 3. Do you see 3 anywhere in that equation? Right here. If we were to put 3 in there, 3 minus 3 would give us 0. So the vertical asymptote is the x value that would make the bottom equal 0 because we can't divide by 0. So our vertical asymptote is x equals 3. Our horizontal asymptote is a little bit weirder to find because I think it's just, they're so far away, it's a little bit more difficult to see it. If you have a straight edge, you might want to put a straight edge along there until you find it. This horizontal asymptote is at y equals 4. Do you see 4 anywhere in that equation? Why, yes, we do. That plus 4 indicates up 4. The minus 3 indicates right 3. So all of the rules that we've been taught about how functions move, that still applies to these hyperbolas. So the number that is with the x is backwards. Minus 3 means right 3, and that shifts that asymptote. Instead of being at 0, it shifts it right 3. The plus 4, that means up 4, so instead of the asymptote being at 0, it shifted the asymptote up 4. Once you know the horizontal and the vertical asymptote, the domain and the range are really, really easy. The domain and the range are both all real numbers, except in the domain, x cannot equal 3, and in the range, y cannot equal 4. Those are asymptotes. The graph is never going to touch those, so it can't be that. And let me pause quick. So here I have that same graph on my graphing calculator. And if we look at the table, when x is 3, there's an error. X cannot be 3. And if you look in the y values, you'll see the y values approach 4, but never actually get to 4. So you can kind of see those asymptotes in the table, but it's almost easier just to look at the graph, or honestly look at the equation. You can see the asymptotes in the equation. Okay, so if we look at number 2, according to the equation, we have x plus 3. That indicates left 3, so the asymptote moved over here to x equals negative 3. The minus 1 indicates that we moved that whole hyperbola system down 1, so our horizontal asymptote is at y equals negative 1. Because there's an asymptote at x equals negative 3, the domain, the x values, can be anything except negative 3. the range, the y values can be anything except y cannot equal -1. So if we look at this generic form, y equals a over x minus h plus k, the vertical asymptote is going to be x equals h, because h minus h would make that bottom be 0. So basically the opposite of whatever you see in with that x. The vertical asymptote is y equals k. All right. This first one I am going to graph using this graphing calculator, and this will work on whatever type of graphing calculator you have, whether it's an 83 or an 84. So to graph this, we go into y equals 1 divided by parentheses x plus 2, close your parentheses, minus 4. You have to put parentheses around the bottom so it doesn't just do 1 divided by x and then do plus 2, like moving it up 2. You have to get parentheses around that denominator. Okay, we look at the graph. You can look at the graph to figure out the vertical asymptote and the horizontal asymptote, or you can look at the equation. The vertical asymptote is going to be at -2, because -2 would make the bottom equal 0, and that plus 2 means left 2. The horizontal asymptote is going to be at -4. You can also write in your domain and range right now. X can't be -2, y can't be -4. And on your graph, go to an x value of -2 and put in a dashed line. And for your horizontal asymptote at -4, put in a dashed line. Okay, we are going to pick some x values directly around this vertical asymptote. So our vertical asymptote is at -2. I want -1 and 0. I want right here and right here. I also want -3 and -4. So 2 x values on either side of that vertical asymptote, and then use your graphing calculator to figure out what those are. So in your table on your calculator, -1 has the y value of -3, 0 has the y value of -3.5, sorry, that's my daughter. -3 has the y value -5, and -4 has the y value -4.5. Now you can graph more points than this, but we would start with -1, -3, 0, -3.5. I'm being climbed on at the moment. That's why that point looks so crazy. And the point -3, -5, and -4, -4.5. And if you look back at the graph, you'll see that it very sharply goes toward those asymptotes. Don't touch them, don't cross them. If you appear to touch them, that's fine. Just make sure that you're not crossing them. And that's it. Number 4, I'm going to graph using Desmos. So if you don't have a graphing calculator at home, we can use Desmos to graph this. So go to desmos.com and click Start Graphing. And remember, this is always blank. We are graphing, it says f of x equals, you can type that in, or you can type in y equals, it does not matter. And then we do 2 divided by. When we do 2 divided by, notice it puts this at the bottom. So we want x plus 3 at the bottom. And that does this for us. Now, a couple of things I want you to notice is this one has been shifted left 3. It has not been shifted up or down at all. So we have that horizontal asymptote at 0. Our vertical asymptote is right here at -3. So if we go back to our notes, which are here, our vertical asymptote is at x equals -3. Our horizontal asymptote is still at 0. So then for our domain and our range, our domain is x can't equal -3. Our range, y can't equal 0. And let's put that in here. So -3, that gives us this vertical asymptote. Y equals 0, I go ahead and put a dashed line along the the x-axis on that y equals 0 line. We're going to want 2 points on either side. So from -3, I want -2 and 0. That's the 2 points on the right side of the asymptote. 2 points on the left side, I want 1, 2, 3, -4 and -5. Okay. In Desmos, remember to get a table, you click on this little wheel, and then you click this little Convert to Table button. And we decided we wanted -2, 0, -4, -5. So notice it doesn't have all the ones that we want. So you click here and type in -4 and then enter, and then -5, enter, and it makes those points for you. So -2, the point is at 2, at 0. Oh, I didn't want 0. I want -1, don't I? You guys need to correct me when I make mistakes like that. So at -1, we want the y value of 1. So notice that's right here. And then -4, the value is -2. And at 5, the y value is 0.25. So let's graph those. -2, 2. -1, 1. Now we could also graph 0.6 and 1.5. Like we could graph more of these if we wanted to. And then on the other side, -4 is -2. And 5 is 0.25. And if you want to look at the graph again when you're drawing this in, you can. A couple things to remember, and I kind of felt myself kind of almost doing this, but when you graph these, you definitely don't want your graphs to look like this. Okay, we are not graphing fish hooks. These ends need to approach the asymptote, not curl back in. So make sure when you're graphing that your ends don't curl back around. You need to approach your asymptote. Okay, number 5, I'll go back to the graphing calculator for those of you who have the graphing calculator. This one's just a little bit odd because on the bottom it's 2x plus 3. We haven't seen anything like that before. It still has a plus 0 here. So the horizontal asymptote is still 0, which means our range is still y can't equal 0. The vertical asymptote is going to be where that bottom equals 0 because we can't divide by 0. So if I solved this, I would get x equals -3/2 or -1.5. So the vertical asymptote is actually at x equals -1.5, which means our domain is x can't equal -1.5. Now, disclaimer, I won't give you a crazy one like this on a test, I promise. Okay, so -1.5, that means our asymptote is right in the middle here, and our horizontal asymptote is still at 0. So a couple points around, we can do -1 and 0, and then we can do -2 and -3. So if I put this graph in here, 3 divided by parentheses 2x plus 3, we can see it on the graph. Go into our table, -1, 3, 0, 1, -2, -3, -3, -1. So -1, 3, 0, 1. If you wanted to put more points on, you could. -2, -3, and -3, -1. So draw in that hyperbola.